Okay, good day everyone. Our topic for today is three-moment equation. Okay, three-moment equation is under the exact method. Okay, kasi in indeterminate structure, we have two methods, the approximate method and the exact method. So, of course, from the word approximate, it will give you an approximate answer. And for exact method, it will give you the exact answer. Okay, of course, in the level of difficulty, approximate method will be easier to solve, to do, than the exact method. Okay, and of course, we already know how to determine if the structure is indeterminate. Okay, so let's proceed to three-moment equation. At the end of this video, you will be able to use this method in solving indeterminate structures. Okay, so let's proceed to the three-moment equation. So from the word three-moment, we're going to need this three-moment equation is used to solve continuous span beams. Pag sinabing continuous span, two or more span po. Okay, that yung pwede nating i-consider. Of course, from the word three-moment, okay, so three, we'll be needing 3 points or 3 supports to consider in this method. Like here in our figure, we have considered uh, 3 internal roller. So internal roller A, B, C. So we have 3 points here. 3 points A, B, C. And we agree that each point here has a internal moment. Okay, we have MA, we have MB, and we have MC. Right? Okay, yun po yung ating magiging 3 moment. And we have here, in this equation, we will consider only 2 spans. Okay, the spans, or the span that is between the points. Okay, so we have for the span AB, that let's say the length of that is L1, and for span BC, the length of that is L2. And each span meron siyang, let's say, meron siyang sariling I1, meron siyang sariling E1. Okay? And then for BC, let's say this is your I2, this is your E2. Okay. And then some problems, okay, some structure, merong tinatawag na settlement. Okay, yung settlement natin, let's say, this is your point A, bumaba siya like this. Okay, may settlement. So, let's say that is H1. And then, of course, sa kabila naman, may settlement H2. Okay? And then, in this three-moment equation, meron tayong tinatawag na derived equations. Okay, so we have general equation here, as you can see at the right part, labeled 1, equation number 1. Okay, this is the general equation of the three-moment equation. So, ito yung una, MA. Okay, yan po yung moment natin sa left part. Okay, pinaka-left point o yung unang-unang point po natin, MA. Okay, times L1. L1 is the span at the left. Okay, itong L1 po natin. Ito yung span sa left. All over yung property po ng span na yon, EI ay E1 ay 1. Okay? Plus 2 MB. So, MB, ito po yung moment sa gitna. Okay? Yung second point sa gitna. Times 2. Okay? So, 2 MB. The quantity L1, yan po yung left span. All over yung property ng left span, E1I1. I-add po natin siya sa L2. L2, yan po yung length ng right span. All over E2I2, yung property po niya po ng span na yan. Okay, then close parenthesis po tayo. Plus MC here, plus is the moment at the last point o yung po nasa right. Okay, times po yung span ng right, yung length po ng span ng right, all over yung property ng span na yun, E2I2. Pa-plus natin sa factor ng 3-moment equation that I will discuss mamaya, which is 6A1 times A all over E1I1L1 plus 6A2B all over E2I2L2, which is equal to 6 times H1, yan po yung settlement sa left, all over L1, plus H2 all over L2, which is the settlement at the right. Okay, ito po yung magiging general equation natin. Okay, this is when meron pong settlement. Okay, may H1, H2, at merong pagkakaiba ng property ng bawat span natin. Let's say, iba yung E1 for the left span, iba rin yung E dun sa right span. And then, iba yung I dun sa left, dun po sa right span. Okay, pag nangyari yan, ito po yung magiging general equation natin. And then, if E is constant all throughout the span, E1 is equal to E2, constant siya, and then also I1 is equal to I2. Parehas po yung I nila, and parehas din yung E. Ang magiging simplified equation natin, which is, we'll have, kasi parehas naman yung E saka I, dito sa left part na to, we can now transpose this to the right part. Okay, which make us, yung right po, yung EI sa baba, okay, ng bawat term sa left, as you can see here, nawala ng EI dito. Okay, nilipat na po natin doon sa right. Okay, kaya mapapansin nyo, imbes na 6 na lang, like this, 6 na lang, minutupay po natin yung EI. Yun lang po yung pagbabago. Okay, if EI is constant. Alright? And then next po, what if walang settlement? Hindi po bababa yung mga points natin. Hindi bababa yung A, hindi rin bababa yung C, and pati yung B. Pag nangyari po yun is, mawawala po yung H1, 0 to 0, which make us, okay, the equation number 3. This is when H1 and H2 is equal to 0. Okay? So that's it. Ito po yung magiging equation natin. If walang settlement. And then, EI is constant. That is equation number 3. Okay, so before we proceed to an example, let's discuss yung factor na sinasabi dito. 6A1A all over L1. Okay, L here is the length of the span. Let's say ito po yung magiging span, left span natin. Okay? Left span. This is your point A, point B. And then, this meron po siyang load. Baga. Of course, pag may load yan, we can draw yung kanyang moment diagram. Let's say this is your M diagram. Okay? Of course, yung area po niyan, let's say that is A1. Yung area ng moment diagram. And then, going to get the centroid. Okay, 6A1A yung A po dito, class, is yung distance from the left. Okay, this is your A. Alright, so using this formula, class, so para makuha po yung value ng 6A1A all over L1, yung A1 here, ito po yung area ng moment diagram. So you can compute that. Yung A dito, yan po yung distance from the centroid of the diagram to the left part. And L1 here, of course, the length of your span. Okay? Ganun lang po. So, 6, given na yan. Constant yung 6 na yan. And A1, yan po yung moment po ng ating area po ng moment diagram. And A is the distance or moment arm from the left part. Okay? All over L1. So, pagkakaiba lang po ng sumunod na ano natin, 6A2, term natin 6A2B, sinabi, all over L2. Let's say, meron pang yung second span natin dito. We have here the second span, the right span, say, the right span. Of course, parehas sila, magkakaroon sila ng area. Okay, let's say A2 to. And then, ito yung centroid niya. So, yung B here, as you can see, is the distance naman from the right. Ito yung B sa formula natin. And of course, L2 here is yung length po ng span or right span. Okay? So, ganun lang po siya. Okay, so let's proceed to the example. Okay, ito po yung ating example number 1. Okay, ito yung example number 1. So, we have here the given. Okay, ito po ay 2-span beam. Sabihin, continuous beam po ito. So, as you can see, let's determine first if it is, of course, indeterminate. No? So, we have how many reactions? We have 2, 1, 1. So, we have 4. Then, how many member? So, n. Ilan yung n natin? So, we have only 1 n. So, R, 3n. Tama? So, yung R natin 4 times 3n. So, 4 is greater than 3n, which is 3. So, therefore, indeterminate po ito. 2, ilang degree? To the first degree. Okay? So, as you can see here, first degree, indeterminate po siya. And then, sasabihin ko na lang din na the number of equation that we're going to use is equal to the number of degree. Kasi yan yung number ng unknown or yung redundant na sinasabi natin. Okay, kung ilan po yung redundant, yun po yung magiging number of equation natin. Pag dalawa yung redundant o yung degree of indeterminacy, dalawa po yung magiging equation natin. Okay? So, let's solve this. So, ang required po is draw the shear and moment diagram for this problem. Okay? So, before we draw the shear and moment diagram, we need first to determine the reaction. Doon na po papasok yung ating 3-moment equation sa pag-solve po ng reaction natin. Okay? So, as you can see dito, walang binanggit about EI. So, we assume na constant po yung EI. Okay? Constant EI. And then, hindi rin po binanggit kung magkakaroon ng settlement. So, we assume po na no settlement. So, ano magiging equation natin? General equation. Or, 3-moment equation na gagamitin. Is it number 1, 2, or number 3? Okay, very good. We're going to use the number 3. Yung EI is constant and no settlement. So, ano yung formula? Yes, MA L1, tama? Plus 2MB L1 plus L2 plus MC L2 plus 6A1A all over L1 plus 6A2B all over L2, which is equal to 0. Okay? Next tayo. Ngayon, tignan natin yung mga term na kaya natin i-define. Okay? Yung L1 given naman yan. L2, yes, given. L 6A1A all over L1. Ito po yung ating kukunin muna. Okay, before we proceed in substituting the value. Okay, so muna tayo sa 6A1A all over L1. Okay? So this, ito po ay pang first span. So ano ba yung tsura ng first span? Ano yung left span natin? Ito yung left span natin, di ba? So itong load na to, the first span, i-carry po yan ng simply supported. Simply supported lang po. This is 45 kilonewton per meter. Ng kanyang span is 8 meter. Ito po yung kanyang L, length. Okay? And then, as I discussed a while ago, we need to determine the moment diagram of this. Okay, so to do that, syempre ang moment diagram nito is, sino nakakalam ng uniform distributed load? Okay, ito po ay parabolic. Okay? Okay, so if parabolic yan, ano yung magiging value natin dito sa maximum moment? Yung maximum moment na sa gitna, which is equal to, let's say, we have here the reaction of your left span. So, ang reaction niyan is siyempre 45 times 8, kalahati lang po, divided by 2, which is 180. Ito po ay 180, 180. Okay, so, sige, i-draw ko muna yung shear diagram para hindi po kayo malito. Para alam nyo kung ano yung maximum moment. Pero I suggest po na you need to already familiarize yourself in how to get the moment diagram even without drawing the shear diagram. So of course this is 180 and this is 180, which is negative. Okay, and then dahil parehas na 180 yan, we can conclude here na the same po yung length niyan. That is equal to 4 meter. And if you're going to plot or draw the moment diagram, so from 0, we need this area. So ang area nito is 180 times 4 divided by 2, 1/2 base times height, so 360. So maximum dito from point A to gitna is 360, and then from that, ito po yung ating moment diagram. Okay, so you can also do it by moment diagram by parts. Okay? Right, so next po is to determine the centroid. So, ang centroid po nito, as we all know, na ay nasa gitna ng ating area of the parabola. So, this is, kung yung buong span is 8, kalahati nun, which is equal to 4. So, ang area nito, ng parabola is, class, 1/3. Yes. 2/3. Kasi nga parabola. Base. Okay, times. So, ang base po natin dito is 4 times 2. 8 po. 8. Yan natin base. So, 2/3 base. 8 times height. Anong height niya? 360. So, we have 1920. Okay, so using this formula, 6A1. So, A1 is 1920 all over A. So, A is 4 over L1. L1 is 8. Okay, so we have an answer here. So, lumabas dito is 5,760. For this formula, 6A1 A all over L1. Okay, for the right span, ganoon na ganoon pa rin po ang gagawin natin. Simply supported pa rin po ang yung mag-hold dito. But the same span po na sa original, we have 6, we have 2. And then from that, we're going to determine yung mga reaction first. So, we have, mag-moment na lang tayo dito. Sa point C, to sa point B dito. Okay, to get the reaction at point B using segment BC. So, we have 70 times 2. 70 times 2 divided by 8. So, 17.5. And then for the next, yung ating C, $52.5. Pag in-add natin, 17.5 plus 52.5, we have 70 here. And then we now draw the shear diagram. So we have negative 52.5 and then 17.5. Then we're going to draw. Ay, wait lang. Need to correct this. Yan, ulitin natin. Okay, so we have 17.5 constant. Bababa po ito. And then dito. Yun. Mas better po tayo dyan. And then from that, so from 0 yung uh, pin natin sa point A, then 0 sa point C. Then we connect. Okay. So ito na yung ating moment diagram. And then yung height po nito is equal sa area nito. So ang area nito is 17.5 times 6. So 105. This is 105. Okay, so dito po pwede natin po hatiin yung triangle natin. Okay? So, dalawa na po yung magiging area natin dito. Area 1, and then we have area 2. This is your area 1. This is your area 2. We're going to get the distances here from the centroid to the right. So, we have 2 po yun, no? 2 ay times 2/3. 4/3 po yun nandito. Ang distance. And dito naman is 2 plus 1/3 ng length na 6. So, it is 4. This is 4 meters. Okay, so using this formula, itong second po dito for the term, 6A2B all over L. So, 6 ang area po natin for A2 here. Which is 1/2. Base is 6. Ang height po natin is 105. Plus 1/2 times 4/3. Okay, times po natin ng B or ng L over 2. So, ang B po nito is 4 na to. So, 1/2 po base times height. So, ito is 2. Tama? So, hindi to 4/3. Dapat 2 to kasi area pa lang tayo. So, ito yung 105. Area pa lang. Nakalimutan natin yung B dito. So, makiba kasi yung B ng bawat area. Okay, so, let's remove this. So, times B muna tayo. Times B. Ang B nito for area 1 is 4. Then, i-add lang natin ulit yung para sa A2. Ito. So, we have 1/2 times 2 times 105 times centroid 4 over Of course, lahat po yan over L2, which is 8. So, ano magiging sagot dito? Compute natin, 6 quantity, 1 half, times 6 was 105, times 4, i-add natin second, which is 1 half, times 2, yung kanyang base, yung height niya is 105, tapos, kanyang centroid from right is 4/3. So, 6, 1 half times 6. Okay, area yan, times 4. Plus natin yung 1 half times 2. Yung kanyang base, and yung height niya is 105. Kanyang centroid is 4/3. Okay, and then, lahat po lang ito, ay divide natin ng 8. That is 1,050 rather. So, this is your 6A2B all over L. Okay? And then after this class, after none, we can now use the equation dito. Okay, so we have MA, tama, MA, L1. So, ano yung L1 natin? So, ang L1 natin class is ito, di ba? First span 8. L2 here is also 8. So, MA, L1, which is 8, plus 2MB times 2MB times L1 plus L2. So, 8 plus 8 plus MC times L2, which is 8, okay, plus 6A1A all over L1. So, yung una is 5. Open first, no? So, wala is 5,760. Okay, so I have 5,760. And then, for the next, okay, so ang next natin ay 6A2B. So, ang lumabas is 1050. Okay, plus 1050, which is equal to 0. Then, next is 8MA plus, so 8 plus 8, 16, so 32MB plus 8MC. Then it's going to add this and then transpose natin sa kabila. So we have 5,760 plus 1050. So we have negative 6,810. And the next, as you can see here, isa lang po yung degree natin. So isang redundant. Bakit ito tatlo yung moment na? No. Okay, so we can determine yung mga moment natin sa mga end supports. Okay, tignan natin muna, no? If pin po yun nandito, ano yung magiging moment yan, actually? Of course, MA here is 0. Yung moment. Okay? Kasi ano po yung end ng ating beam. Okay, so 0 na yan. And then, ganoon din po sa ating MC, which is also 0. Okay, so, removing this term and this term, we have 32 MB is equal to negative 6,810. So, ang MB po natin, moment sa B, is negative 6,810 divide lang natin ng 32. So, we have negative 212.8125 kilonewton meter. So, para sa sign convention, pag negative po ito, MB, okay, consider po natin yung sign sa ating moment. Okay? So, pagka positive moment, if considering right, left, okay, left na structure, so ang MB po natin is counterclockwise, di ba? Dapat nag-i-smile yan. Then, pag sa right naman na kinoconsider natin, of course, dapat po ganyan. Yung ating rotation. So, pag negative yan, this is positive rotation. Okay? Rotation. Pag negative, of course, that is opposite. O negative po, so i-opposite mo lang ito. Okay? Yan yung ating MB. So, now how can you determine the reactions? So, to determine the reaction, cut po natin yung span AB. Ito yung ating AY. Then we have here let's say this is your segment AB. Consider natin segment. Of course, pag kinat na dyan, we have here the moment. Okay, dito na papasok tong MB. Okay, so negative 212. Pag negative po yan, ganito po yung ikot. Okay? Negative po. O, ganyan yung ikot. Which is equal to 212.8125. This is your 8 meters. Ang weight niya po is 45 kilonewton per meter. Okay, and then, of course, meron po tayo dito yung shear sa ating B or reaction ng ating B considering AB segment. So, let's say this is your B1. Okay, hindi pa yun yung B1, yan pa lang yung B1 kasi may B2 dun sa kabilang segment. Okay? So, if we're going to have a moment here sa point B, summation moment, at point B is equal to 0 positive clockwise. So we have negative 212.8125 negative AY times 8. And then so ito positive pala to, no? Positive kasi clockwise siya. Then we have of course negative. Ito yung positive pa rin kasi clockwise. Ito pala positive to. And then yung next po is ito natin, point natin, ikot positive, clockwise, ito na po negative. So minus 45 times 8 times 4 is equal to 0. What is your AY? So I have 212.8125 minus 45 times 8 times 4, negative 1227.1875. Okay, kindly compute it plus, so lumabas is 153.153.398. So let's say 0.40. Okay, so may AY na tayo. Summation moment at A naman tayo to get B1. Okay, so i-direct calculate na natin, no? Pwede naman. So what will be your B1? And pag in-add ko, dapat equal sa resultant force ng 45 times 8. Okay, to check. So, i-check ko na kasi medyo inaantok na tayo. So, check natin. So, mag-moment po ako sa A. So, we have B times 8. Okay, negative yon. Then, plus 212.8125. Then, plus 45 times 8 times 4. So, B1, the lumabas na B1 is 206.60. Okay, 206.60. So, pag i-add po natin dito, dapat equal siya sa 45 times 8, which is 360. So, 153.40 plus 206.60. So, 360. So, tama po yung A1, AY, B1 po natin. And then, ganun po rin gagawin nyo sa kabila. The same lang po ang gagawin natin. Okay, so consider here, ito yung ating B2, and this will be your span number 2, ang right span 70 to, and ito CY. Okay, so summation moment pa rin tayo. And then of course, ito po yung ating MB. So, negative siya. So, ano yung sign or yung rotation pag negative yung MB? Considering the left or the right, to say. So, right siya. So, clockwise ang positive. So, counterclockwise po ang negative. So, ito yung 212.8125. The moment tayo sa B, at B is equal to 0, positive clockwise. So, lagay po natin yung mga dimension para hindi mawala. So, we have first negative 212.8125 plus 70 times 6. And then we have minus. So, minus to CY times 8, which is equal to 0. So, what is your CY here? Login 212.8125 plus 70.6. Okay, divide lang natin siya ng 8. Which is, ang CY po natin is 35.43. And then, for our B2, mag-moment po tayo sa point C naman. Okay, to check lang, 70 times 2. Negative yun. Okay, then negative yung 212.8125. Positive alpha x yung B2. Okay, times 8 is equal to 0. 70. I-compute lang guys. Tuloy-tuloy lang natin. Ang sagot po dito is 4.10. So, check natin if 70. Yan. So, ito, hindi po siya nag-70. As you can see here. So, double check lang po natin ulit. For the B2. So, gumamit ako doon. So, 8 times B2. So, lumabas for B2 is 4.10. Okay, for 4.10. So, check po natin yung sa nauna. Baka may mali, no? Kumita ko sa B. So, negative yan. And then, positive. And then, negative. So, ulitin ko po. Negative 212.8.25 plus 70.6 minus 8. Ito po is times po ito times. Okay? Hindi po ata ako ano. So, hindi na po ito yung sagot natin dito. Mag-iba ito ng 25.898 or 90. Lagay natin. Pag i-add natin ito, dapat 70. No? So, 25.90 plus 44.10. So, 70. So, ito yung magiging values natin dito. So, ito po yung sinasabi ko to check. Okay? If tama yung ginagamit nating equation. Okay? And then, lastly, to get by, yan, ito po yung ating gitna. Okay, nandito yung ating by. So, ito yung B1 saka B2. Ito yung sa B1, ito naman sa B2. So, to get by, so simply add lang po natin. Okay, by is B1 plus B2. Okay? That is 206.60 plus 44.10. So, we have 250.7. Okay? And then, next, ito po yung hinahanap, no? Yung shear diagram. Okay, so for the shear diagram, meron tayong AY. Ito yung AY, which is 153.40. Ito yung BY, 250.7. Then for CY, we have 25.90. Okay? So, tataas tayo for the shear diagram. Tataas ng 153. Let's say this is the 153.40. Bababa tayo. Lipat natin po dito. Dito sa part na to. We can now erase ko lang dito. Okay. This is 212. Yan. Okay. So, 153.40 ito. And then, from 0 degree, magiging first degree ito. Okay, so we're going to add here. So 45 times 8, 360. Okay, 360 minus 153.40. I have 206.6. Negative 206.6 po ito. And then, okay, so ganyan siya. Tama. First degree. And then, tataas tayo ng 250.7. So, from 206.6, tataas tayo ng 250.7. So, lalabas is 457. Wait lang. Lalabas is 44.1 dito. We have 44.1. So, from that, straight pa rin. Okay, 0. Nagbababa tayo dito ng 70 minus 44.1. We have 25.9. Okay, so bababa. Okay, from 44.1, bababa tayo 70. So, we'll end up with 25.9. So, ito yung magiging shear diagram natin. Then next tayo, moment diagram. Okay, before we proceed the moment diagram here, let's solve for x. So for the x here, a similar triangle, 153.40 is to x is equal to 153.40 plus 206.6 is to 8. Shift solve. Nalabas po ang value ng x natin is 3.41 approximately. And then going to draw the shear diagram here. So, ang shear diagram natin is from 0. I-add po natin yung area nito. So, ang area po nito is 1/2 base, which is 3.41. Ang height is 153.40. So, lalabas is 261.547. Ito po yung diagram natin. Then, bababa po tayo. From this, okay, ito po yung area nito na kailangan natin. 1/2 base. So, ang base natin is 8 minus 3.41. Na yung height po natin is equal to negative 206.6. So, lalabas is, ang area po nito is negative 474.147. So, add natin yung 261.547. So, lalabas is, mababa tayo dito, ang negative 212.6. Force concave hammer po yan. And after that, nakaroon po yung change in moment sa point na to, which is equal to 44.1 times 6, which is 264.6 minus 212.6. So, 52 po. Okay, so, akit tayo ng 52 dito. And then, lagyan po natin yung line connecting point natin. Force from 0 degree sa shear, magiging first degree po. And then, after that, lastly, we need this value, 25 times 25.90 pala ito. 25.90 times 2. So, magiging 51.8. Approximately po, no? Approximately equal to 0. So, meron 0.2. We can take that as approximately equal to 0. Okay, so ito yung magiging shear diagram po natin. Shear diagram. Then we have moment diagram. Approximately, no? Alright? That's it po. For example number 1. So, take away po natin is how to use this equation here to solve first the moment, and then the reaction, and then the shear moment. Right. So, thank you very much, class. And please wait for the next example.